So for number 6, the first thing they asked us to calculate is the total distance that this ball travels. Okay, so the ball starts right here. This is our initial position. It is first passed to this person. So that's a distance of 3 meters. That person then hits it over this person's head all the way over to here. So it travels 3 meters this way, 3 meters this way, and then another 5 meters that way for a total distance traveled of 11 meters. Okay, remember, it goes 3 meters and then 3 meters back. That's 6, plus another 5 is 11 meters. Okay, it's very common for us to have a gut reaction that says 8 meters because we see the 3 and the 5 together, but we forget that it travels the 3 meters twice, there and then back over the person's head. Okay, now the total displacement's quite a bit easier. This is the initial position and this is the final position. It's 5 meters to the right of the initial position. So our displacement is just 5 meters right. Everybody with me on that? Okay. Now we're going to go into a little bit more stuff here that's still review of Science 10, okay, but we got to look at using V equals D over T, okay, remembering kind of our rules of algebra, all right? In physics, we always say that there are only 3 rules to effective algebra, okay? The first rule is if you want to move something, you do the opposite, okay? If what I do to one side, I need to do to the other side of the equation. And kind of the third rule is if there's lots of things to move, I move what's not attached to what I'm looking for first, okay? That's not really, that third rule doesn't apply to all equations. In this equation, it doesn't apply. There's only 3 things, all right? So let's say I want to manipulate V equals D over T for D, okay? Do I want to leave D where it is? Okay. Generally, if something is on the top of an equation, I can solve for it there. So I probably want to leave D where it is, okay? Which is going to mean that I'm going to need to move T over to the other side. Right now, I'm dividing by T. The opposite of divide is multiply. Okay, so that means I'm going to multiply both sides by T, and T is going to come over here. All right, so now I've solved for D. D equals V times T. Everybody all right with that? Okay, now, whoop. That all to go together. Okay. What if I want to solve for T? Right now I've got D divided by T. If I just move D over to this side, will T be on the top or the bottom? It'll still be on the bottom. The reason being is if I divide both sides by D, D divided by D is 1. So there would be a 1 that would stay there. Right? And I don't want 1 over T, I want to solve for T. Okay, so what I'm going to do is the same thing I did to start off my last one. I'm going to multiply both sides by T. Now T is on the top of the equation, but it's not by itself. How do I get it by itself? What should I move next? Addison, what should I move next? V. Okay, so I'm going to divide both sides by V. Now I've got T. Right? If you're ever unsure of a manipulation, you can always double check your units. Okay? In this case, I've got D divided by V, which would be meters divided by meters per second. What's going to cancel? The meters. I'll be left with seconds, which is the units for time. Okay? I can always double check and see if I've manipulated it right by checking to see if I get the right units. All right? Okay. This is a question I would have given my Science 10 students, okay, kind of, let's say 5-6 days into the physics unit in Science 10, all right? It's a average velocity, average speed question involving a trip with many parts, okay? I'm going to give you guys a couple minutes to try it, see if you can figure it out before I go over it with you, okay? The thing you need to remember about this question is that average velocity is total displacement divided by total time. Okay, if you're going to find the average velocity for that whole trip, you need to know the total displacement over the whole trip and the total time over the whole trip. Okay, give you a few minutes to give it a try. Our first step, if we have a question that has a trip with more than one part, is to separate it into the parts. Okay, that way we can deal with them one at a time. All right, so in the first part of this trip, okay, we have the truck traveling at a velocity of 4 meters per second north. Okay, and it does so for 12.5 seconds. Okay, the other part of this question, okay, or this trip, sorry, is that the garbage truck travels 26 meters south, so that's a displacement. How do I know that? How do I know that 26 was a D and not a V? Austin, how do I know? Okay, it's a vector quantity, but how do I know it's not V as opposed to like V with the arrow versus D with the arrow? No. What are the units for it? The units for it are meters, okay? And the direction is south, right? So I know it's a vector quantity because they gave me the direction, but it said it's 26 meters. That's the displacement, okay? It's not a velocity because that would be in meters per second, right? So I can tell kind of what I'm given by looking at the units, right? The other thing they tell me is that the velocity of that thing is 16.0 meters per second, and that's also south. Okay, I need to know the total displacement of this truck as well as the total time for the whole trip. Okay, I don't have the displacement of the truck in part one, but I have V and T. So can I find the displacement of the truck in the first part? Yes, I can. I just have to manipulate V equals D over T. All right, so I've got V equals D over T, and I'm going to solve for D. Okay, so I'm going to multiply both sides by T, and that'll give me D. Okay, T times V equals D. So 12.5 times 4. Okay, that'll give me the displacement of the garbage truck during the first part. I can't believe I did that. Okay, 50. Okay, 50 meters, and that'll be north because it was traveling north according to the velocity. All right. In the second part, I don't have the time, and I need to have the total time. So I've got to have the displacement for both parts and the time for both parts. So can I find the time in part two? Okay, so again, V equals D over T, and I'm going to solve for T. So T equals D over V. That's going to be 26 meters divided by 16 meters per second. All right, so that's going to take 1.625 seconds. Okay, I now know that it went 50 meters north and then 26 meters south. So what's the total displacement? Okay, essentially the garbage truck did this. 50 meters north, 26 meters south. What's left? How far am I from where I started? 24 meters, right? Let's go 50 minus 26, right? My total displacement, okay, so this number here, my total displacement is going to be 24 meters north. All right, can I find how long the whole trip took? I know the first part took 12.5 seconds. I know the second part only took 1.625 seconds. So can I figure out what the total time is? Okay, how do I do that? Davis, what do we do? Before that, I'm going to do that in a minute. If I want the total time, this part took 12.5, that part took 1.625, add them up, right? All right, so my total time, okay, is going to be 14.125, right? I probably shouldn't add stuff in my head. Okay, so I know my total displacement is 24, and I know my total time is 14.125. Right, so the average velocity then, V equals D over T, okay, is 1.70 meters per second north. Okay. Everybody follow there. All right. Using that same information, I want you to now calculate the total distance traveled and the average speed for that trip. Okay. We just did the vector one. Now I'm asking you to do the scalar part. Okay. What's the total distance traveled and the average speed over the whole trip? Okay, so like I said, we just did the scalar part, or sorry, the vector part of all this. Now we need to do the scalar part. Okay, so our numbers we can keep. Okay, there's nothing wrong with the numbers that we have for part 1 and part 2. It's just now we're going to look at them as though they don't have any direction. Okay, that's the only thing that's going to change, because now I'm calculating the speed, the average speed of the object, which means now I don't have any arrows over top of any of my variables. This is going to be total distance over total time. All right, my total distance is, well, I went 50 meters and then I went 26 meters, which is a total of 76 meters. Okay, and my time is still exactly the same. It's the same trip. Okay, it's still going to be 14.125 seconds. All right, so when we do that, okay, we got 5.38 meters per second. Right? No direction on that because it's a scalar quantity. It's speed. Is that ringing a bell a little bit? Okay? Hopefully it is, because you would have done stuff like that in Science 10. In fact, I had a garbage truck question on my final exam one year. It was just like this one. Okay. All right. I want you guys to try that one. It's just a V equals D over T question. Okay, simple V equals D over T question. Give it a try and then we'll walk through it together. Okay, so let's have a look at this one. First thing I want to do anytime I'm solving a problem in physics is write down the givens that the question gave me. Okay, it says average speed 67 meters per second. All right, so I'm going to write V 67 meters per second. How long does it take the Falcon? So how long? That's time. Okay, so I'll be looking for T. To dive to the ground along a 150 meter path. Meters measures distance, so 150 meters. So I've got V, I've got D, but I don't have T. Okay, so V equals D over T, and I'm solving for T, which means multiply both sides by T, and then divide both sides by V. All right, so I'll end up with T equals D over V, 150 meters divided by 67 meters per second, okay, will give me a time of 2.2 seconds. Okay, everybody all right with that? All right, I'm going to spend a little bit of time kind of practicing that today. So you're going to need your digital workbook, okay, from the About tab in there. Okay, so just open that up here. I'll put it up on the board as well. Okay, so if you don't have it available on your phone, okay, it's up here on the board. Right, I'd like you to, let's say, do like 2 through 8 for today. Okay. One of the big things in these questions, guys, is reading them carefully, because sometimes a question gives you information that is extraneous, that is, it's extra and you don't need it. Okay, like question number 2, there's one number in there that you're not going to use. Okay, question number 2 is not dealing with the average of the runs, it is dealing with each run separately. Okay, so run 1 is to the right and run 2 is back to the left. Right, so keep that in mind when you're doing that one.